I don't have DigitalOcean account. Crazy. Okay, by the way, let's as I'm live right now, so let's continue with this. And hello everybody, here we are. And finally, in this live, we are gonna be talking about many things. First of all, we talked about a lot of stuff yesterday too. And let's continue from there on. And of course, I'm learning about Kubernetes. So that's the learning that I'm gonna be sharing with you guys. Okay. So before even that, let me make sure that everything is up and running. And this is the one that's live right now. Let me delete this one. And just a sec, coming back to this one. Hope everything's clear right now. And of course, I couldn't really go live in the morning because I was busy covering the learning section, learning stuff of Kubernetes. And as that is done right now, so we are gonna be talking about this stuff here. I hope I'm audible. Learning section. Yeah. So without any further delay, let's simply get started. And these are the things that I'm gonna be covering here. So ultimately, everything from here. Even we did quite a lot of things yesterday, and we are gonna be just simply getting the things done today too. And let me go to projects, learning, and I'm gonna be creating one more folder over here. That would be Kubernetes and self or self Kubernetes. Kubernetes self. Okay, this is gonna be I mean everything is gonna be written by myself, and that is why I'm naming it self, nothing else. What's wrong with this? Yeah, it's working now. Alrighty, so this much we've done. And as for the images, we are gonna be just simply using the images of Nginx and MongoDB for right now only, because if we want to build the image, also so even we have the images, so we don't really need to worry about it anymore. I mean, if I talk about the images, so not this one, yeah. I think I have only one image over here. I have deleted all the ones. Okay, never mind. But if we want, we can just simply pull the image from the Docker Hub, and we can just simply use them. But again, right now to keep it simple, I'm gonna be using the image of Nginx and MongoDB, and this is how we are gonna be going ahead. The first thing is that what are we gonna be going through? So if I open this eraser here, on eraser I have just the flow overall, how it works and all. So first of all, we are gonna be talking about the flow, and after that we are gonna be going ahead with the things. Yesterday we talked about all these things, that we have Kubernetes cluster, top level Kubernetes cluster. Inside that we have control plane. Inside the control plane we have API server, control manager, cloud control manager, etc. That is just for the storage, and schedulers. What is the job that they do? I'm not going to be talking much about them because we talked about them yesterday. Coming back to this one, apart from the master, there is a master node, and that master node is called control plane. We have worker nodes as well, and they're simply nodes. And nodes is nothing, just a machine, and that is running inside the Kubernetes cluster. And then inside the nodes we have kubelet and we have kproxy. Kproxy is mainly used for creating the internal network, so that you can just simply talk to the nodes and all. So you will send a request to the control panel. Control panel will talk to the node and talk to these nodes, and will send you the response back, something like that. Apart from this particular thing, we have kubelet. Kubelets are mainly responsible for running the pods and the containers. And there is something called container runtime. Container runtime is mainly responsible for running the containers. So these are the things that you have inside this, and these are the full forms over here. So we have API server. API stands for API server. We have a cloud control manager, CCM, and we have CM control managers. We have etc. This is the persistent storage. We have kubelet. We even know the use of it. It is mainly responsible for running the pods and the containers. We have kproxy, that is mainly used for networking stuff, and also that you can just simply somehow talk to those nodes via control plane. And then we have schedulers. Scheduler is mainly used for assigning right port to the right node. So we may have lots of nodes, lots of machines. Scheduler's job is to just simply assign the suitable pod to the suitable node. And then we have the node and control plane. So these are the things that we have already gone with. Even this thing we talked about them yesterday a lot. So let's not talk about them right now. Overall, what happens here, we have Kubernetes. Inside Kubernetes, of course, this is the cluster. The cluster name can be anything. By default, the cluster name is kind. You can name it anything. And then we have nodes inside this, and apart from this, we have even master. So this is the overall thing. And what do we do inside this? So first of all, we learned about kind. Kind is mainly responsible for creating the cluster. So if you wanna create the cluster, so ultimately you use kind. So let's ultimately start discussing about the things. So first of all, we created the cluster. Once the cluster is created, then we will start creating the workers. So ultimately, once the cluster is created, so we'll make sure that it has control plane, and it has some workers as well. So worker nodes ultimately, so it has suppose 2 workers. So this is how we will just configure everything, and ultimately kind will be responsible for creating the control plane and workers. Once these things are done, then we will be using a command line called kubectl actually. So what this kubectl do? This kubectl will be responsible for everything else. So ultimately once your workers are created, now if you want to create the pod inside them, so you can create the pods, and once the pods are created, container will automatically be created. So you can just simply create the pod, and apart from this particular thing, using kubectl you can create replica set. What is this replica set? We'll talk about this. You can create even deployment, and this is how you can just simply go ahead with the things. Okay, and let's simply let me do one thing. How many things have I covered so far? Yesterday, how many things I covered? So creating pod, stop the pod, Kubernetes checkpoint. Let me go through the theory section first of all, and after that I will start going through the things from the beginning. Okay, so mainly most of the things we have covered yesterday in the sense we covered how to create clusters and control panel workers. All these things were created. We even covered how to create a pod, how to run an image inside the pod, so ultimately how to run a container inside the pod. And mainly two most important things are going to be replica set and deployment. So first of all, I'm going to be covering the theory section of them, and then we will do it in action. Like we'll actually create everything from scratch, and then we'll go ahead with this stuff. So this is how we are going to be going ahead. And when it comes to checkpoint, this is already, we know about clusters, Node.js, images, containers, pods, etc. This much we have already covered. Let's talk about deployment. A deployment in Kubernetes. Again, before deployment, you need to know about replica set. What is a replica set? Replica set is nothing but the configuration that is responsible for creating the pods. As simple as that. So by the way, alrighty then, finally the call got hung up, and I even informed my mom. Coming back to this one. We need to know about replica set. The question is, what is the use of replica set? Let's talk about them from here. So first of all, I'm going to be talking about replica set over here, because so far we have talked about clusters. We know what the clusters are. We know even what the pods are. We have even created the pods. Right now we are going to be talking about replica set. So what is the use of the replica set? Ultimately, you can, first of all, you created the cluster. Then when it comes to pods, so you can create the pods manually, right? You have to just simply run a command. What is the command to create the pod? It's pretty simple. So if you want to create a pod, so kubectl and create, I forgot the command. Okay, let me go through my notes. What is the command? How to create a pod? Create cluster. Cluster is already created. Not like this. Okay, we can't. We have to just simply run the image, and pod will be automatically created. That's okay. So ultimately, we can just simply run the image using kubectl, and once you're using kubectl run, and the name of the image. So suppose my nginx pod, just like this, and you specify the image name over here. The image name is gonna be nginx, and then you provide the port name, port number. It's not really important, but you can just assign that here too. So this is how it just simply goes on. So this way what you do, this way you just simply create the pods. Once you just simply run this image, so pod is automatically created. So this is the thing that we have covered. So what is the replica set right now? Replica set is responsible for creating the pods, and this handles everything in the sense, first of all, using the replica set, you will be creating the pod. Once it has created the pod, then it will make sure that the pods are actually running and everything's up in everything's fine. So ultimately, if a pod crashes for some reason, so replica set will be responsible for creating a new pod. So it's just like that. Replica set, you will specify everything inside the replica set configuration, that okay, these many pods I want, and if you get more pods than that, replica set will downscale. And if you get less, if suppose a pod crashed, so replica set will make sure that it creates the it creates a new pod. So what is ultimately, it is just a kind of a manager, I can say. It is the top level section, top level top level service that simply manages this. So replica set is nothing but a manager that manages the pods. So it is responsible for creating the new pods, deleting the extra pods. If a pod crashes, then it just simply replaces that with a new one. So this is how it just simply manages the stuff. And apart from this particular thing, there is one more thing that is called deployment. So this is again the configuration. What is the replica set? You just simply configure the things. So configure, you have to just simply configure inside. The name can be rs.ml, the name can be anything. RS stands for replica set. So suppose inside rs.ml you will write everything. Okay, this is how these many replica sets I want. Okay, and replica sets in the sense those many pods are gonna be created, and then inside those pods this should be the image. So ultimately you configure everything inside this. Similarly, you have deployment. What is deployment? Again, you will configure it. This is nothing but a file, and you have to just simply run that file using kubectl. But what will this file do? Deployment is responsible for creating replica sets. So deployment will create the replica sets, and in turn replica sets will be creating the pods. So this is the overall flow. Again, this is you will be configuring it. So this is how it just simply goes. You will again configure deployment. So deployment will be responsible for creating replica sets, and replica sets will be responsible for creating the pods. Pods will be responsible for running containers, and that is it. This is how the overall things are gonna be working. Okay, it's as simple as that. So by the way, inside deployment, you again specify that how many replica sets you want, and as per that you will get the replica sets, and replica sets will be responsible for creating those many containers, right? Those many pods, and inside the pod you may have one container, or many as well. There can be many containers inside the pod too. So this is how it's gonna be going on. And now let's do one thing. Let's simply go through the theory part exactly. Let's know more about it. And once we have gone through this, we will be just simply going through going through real stuff. We will just do it in practical here. So when it comes to deployment, so a deployment in Kubernetes is a higher level abstraction that manages a set of pods and provides declarative updates to them. It's simple. What is deployment? First of all, let's go through word by word. So deployment is the Kubernetes high level abstraction. We got that this is the high level abstraction that ultimately manages everything. So set of pods. Ultimately deployment manages a set of pods. How it manages set of pods? It creates replica set. In turn, replica sets manages the pods. So ultimately deployment does the same thing, right? Ultimately you specify everything here. Deployment will create the replica set. In turn, replica set will be managing the number of the pods and all. So ultimately, yeah, deployment is handling that. Okay, so it manages a set of pods and provides a declarative updates to them. It keeps if there are updates, so it just simply manages that. It offers features like scaling, rolling updates, and roll back capabilities, making it easier to manage the life cycle of the applications and all. Ultimately, let's talk about how this deployment is gonna be helpful, because we could have created pods directly. We could have created just a replica set, but here we are creating deployment. Deployment in turn is creating replica set, and replica set is in turn just simply creating the pods and all. And this is how the flow is going on. So what is the use of creating the deployment? And the answer is pretty simple. Okay, so what happens? You have deployment, right? Deployment configuration. Suppose you have this deployment configuration. This deployment is responsible for what? This deployment is responsible for creating the replica set, just like this. So this is how it should be going on. So this deployment is responsible for creating the replica set. In turn, this replica set will be let me delete this. In turn, this replica set will be creating some pod. So pod number 1 probably. Then similarly there can be many pods as well. So suppose 3 pods are actually running here. So this way it's gonna be working. Pretty simple stuff. This can be pod number 1, this can be pod number 2, and this can be pod number 3. So this is the overall flow that you will configure everything inside the deployment that will in turn be responsible for creating the replica sets. And at the end of the day, let me have some lines here just like this, and this will be responsible for creating the pods. So this is how it's gonna be going on. Inside those pods you will have one or many containers running. So container, what is the container? The ultimately container will be responsible for running the image and nothing else. So you may have one container, you may have many containers running inside a pod. So this is how it's gonna be going on. So inside those containers, pod, you will be having the this particular ultimately, just a sec. This is insane. You will have containers running. So this is how we are going to be going ahead. Now the question comes, what is the use of deployment? The thing is that over the because you could have created the pods automatically on your own, but what we did, we even you could have configured pods. So you can just simply create a manifest.ml file, and the name can be anything, and you could have created the pod manually. Even by running the command, you could have created the pod. But what you are doing, you are using ReplicaSet. Why you are using ReplicaSet? So that ReplicaSet manages everything the right way. If you are just simply creating a pod, then that is not being managed, right? So here you are just using a top level abstraction. Let me keep it somewhere here. Okay, so you are using this top level abstraction that is called ReplicaSet. ReplicaSet is mainly responsible for scaling up, scaling down, all these things. And not only that, even on top of ReplicaSet, this is the abstraction that you are using, that is the deployment. And the question comes, why even we have to use deployment here? And the answer is pretty simple. Over the time, you will be changing lots of things in your code, right? You when it comes to deployment, so you will just define everything here. You will define which how many replica sets you want. You will define what should be the images that are gonna be used. So this is ultimately all the configuration you will define inside the deployment, and on the basis of that thing, this deployment will create a replica set, and on the same configuration all the pods are gonna be created. As simple as that. So this is how it's gonna be going on. So why do we need this deployment over here? And the answer is pretty simple. Right now you have only one version of your image, right? So suppose in Nginx version 1 is running, Nginx latest version is running. Later there could be possibility that new versions are gonna be created. You will be making changes in your code, so ultimately new version will be created. At that time you will have to push the changes to what? You will have to push the changes to the deployment. So ultimately as soon as you make the changes, so this deployment will be responsible for making those changes take the effect, ultimately making those changes actually take place in the real world application. So ultimately, as soon as suppose you made some changes inside the deployment, you made some changes, you change the image name. So what will happen? This deployment will create a new replica set. You had this old replica set running. Okay, suppose inside deployment you configure that Nginx latest will be running, or Nginx version 1 will be running. So for over here you are running Nginx version 1. So ultimately this replica set creating pods, 3 pods it has created. So ultimately all these pods will be running Nginx version 1. Later what happened? You thought you made some changes and you converted it to version 2. So right now you don't have version 1, now you have version 2. So what should happen? Usually all these pods should terminate and new pods should be created, and they should be running version 2. Right now these pods are running what? Right now all these pods are running version 1 everywhere. Ultimately all these pods are running version 1. And what I want, I made some changes in the code, and once I made some changes, so there is version 2. As there is version 2, so now what should happen? I should be getting new pods. These old pods should be terminated, should be drained, and I should be getting new replica sets, not even new replica sets, because of course new replica sets, new pods. So ultimately overall I should be getting everything new because I have the new version. So what will happen? As soon as you make some changes in the deployment, you just make some changes in the configuration. So what will you do? Once the changes are made, deployment will create another replica set. Okay, so deployment will create another replica set that would be using image Nginx version 2. Okay, and once another replica set is created, this replica set will be responsible for creating the pod. So first of all, this replica set will create pod number 1. Now as this replica set creates pod number 1, it will be using this image over here. Just keep this particular thing in mind. In the new replica set that I created, it will be using Nginx version 2. These were using Nginx version 1, and this will be using Nginx version 2. So let me even change the color over here. So overall, when it comes to the color, this should be suppose green. So this way, this is using Nginx version, come on, this one, and same here. So this is how I'm gonna be going ahead. So the new replica set that I created, the first one was using version 1, and the second one is actually using version 2. So this is the overall flow, and that is why we create deployment on top of each other. This is nothing but the abstraction, and this is how things are actually managed. So first of all, I had version 1, and I just configured everything inside deployment, and on the basis of that thing, deployment created the replica set. Why? Because at the end, the replica set is responsible for creating the pods, and inside the pod, I mean, depending on the configuration, one or more containers are gonna be running. As simple as that. Then I changed something, and as I changed something, so new version of the image I got. As I got the new version of the image, I said okay, deployment, you have to run this version of the image. Earlier you was running version 1, let's start running version 2. So what will happen? Deployment will be responsible for creating new replica set that will be using version 2. So new replica set will be created, and this replica set will be creating pods, but it's not like it will create all the pods directly and these pods will be stopped. No, I mean everything happens in the rolling format. I think that is called rolling update. So ultimately it's not like as soon as you deployed version 2, so all the pods running in version 1 will be stopped. No, it happens in a rolling format in the sense, I hope this word is the right one. So what happens, first of all, deployment will create a new replica set. This new replica set will create only one pod that will be running nginx 2, nginx version 2, and now it will check, this replica set will check whether the pod that I have created, this is actually, just a minute, the pod, let me read this, the pod that I have created, this is up and running or not. Simple. As soon as you change the version, replica set got created, replica set started running a pod, and replica set will check the pod that I have started running, whether this pod is actually running well or not. If it is not running, or for some reason the changes that you made, it crashed, I mean that change wasn't perfect, and as soon as replica set got created, replica set started running the pod, and for some reason that pod crashed. So what will happen? These old pods that you had using version 1, they will not be terminated. So if something went wrong on this side, suppose something went wrong, and as something went wrong, so what have I done? Okay, something went wrong on here when you just applied version 2. So add something went wrong. So the previous containers, the previous pods that you had, they will not terminate. They will keep running the same way. Okay, it's as simple as that. And if everything goes right, so what will happen? Everything went right. That's great. As everything went right, so now when replica set knows, ultimately deployment knows that okay, pod 1 is running well, then this what will happen? This pod number 1 will be deleted from here, from the replica set version 1. Still it has 2 pods running. Then what will happen? Replica set will create another pods. So this is how it's gonna be going on. So replica set is gonna be doing one thing. Replica set create pod number 2. Okay, and again all these things are gonna be using version 2. So new pod is gonna be created. As new pod is created, replica set will check again whether okay, is this running well or not. I mean there could be chances that it is not running well. So first of all it will make sure that it is running well or not. If it is running well, then this pod 2 will be terminated. Otherwise it will not terminated. If something went wrong, that pod 2 will still be there. But if everything went right, so it will be removed. And similarly pod 3 is gonna be here. So control D, coming back to this one. New pod will be created. It will check whether everything's working right or not, and once it is sure that yeah, everything is working right, so this pod will be deleted from here. And at the end of the day, the replica set that got created initially with version 1, that will not have any pod running, and the new replica set will have 3 pods running again. So this is how the things actually go on. What's wrong with this? It got deleted for some reason. I don't know how it happened. Okay, so don't blame me for that. Okay, never mind. I don't know what I did. It just got deleted. Let's remove everything. But I hope overall you got the idea how it works and all, and why we need deployment. Deployment is the top level. Ultimately, first of all, we have pods. On top of that, we have replica set. Again, this is nothing but the abstraction. And then we have deployment. This is again just top level managing file that just simply manages the stuff and all. And deployment is responsible for creating the replica sets. Replica sets responsible for creating the pods. Pods will be running the container, and this is how things go on. Okay, so a deployment is a Kubernetes. A deployment in Kubernetes is a higher level abstraction that manages a set of pods, provides declarative updates to them if something changes. So deployment will be responsible for creating new replica sets, and then in turn those replica sets will be creating new pods and all. We have discussed about everything, but unfortunately the diagram that I created, that got deleted. And it offers features like scaling, rolling updates, and rollback capabilities. Even you can roll back in the sense, suppose if something went wrong, so you can just simply go back to the previous version. That is also possible. And capabilities, making it easier to manage the life cycle of the applications. Yeah, that's done. Coming back to the next one, what is a pod? A pod is the smallest and simplest Kubernetes object. It represents a single instance of a running process, in your cluster, typically containing one or more containers and all. What is deployment? A deployment is a high-level container that manages a set of identical pods. It ensures that desired number of pods are running. Well, not quite sure. Deployment is responsible for running the replica sets and all, and in turn those replica sets will be running the pods. Okay, let's go ahead. Key differences between deployment and pod. Abstraction level. A pod is the smallest and simplest Kubernetes object. It represents a single instance of a running process in your clusters, typically containing one or more containers. Okay. Deployment. A deployment is a high-level controller that manages a set of identical pods. Not quite right, because it will be managing the replica sets, and replica sets will be responsible for that. It ensures whatever. Okay, fine. Management pod deployment updates. Pod directly updating a pod requires manual intervention and can lead to downtime. Deployment. Okay, this is just the difference. So you can just know the differences based on the abstraction level, based on the management, based on the updates. Scaling, self-healing. If a pod crashes, it needs to be restarted manually unless managed by a higher level control like a deployment. Yeah, ultimately what happens is for some reason your pod crashed. So if you are using replica set, on top of that if you are using deployment, so it will be recreated, ultimately respawn. But if you are just simply running pod manually, so if it crashes for some reason, so you will have to start it manually as well. Deployment, or call it replica set, automatically replaces failed pods, ensuring the desired state is mentioned. So ultimately, overall, you can just, whenever I say deployment, that ultimately refers to the replica set, because at the end replica sets are the ones that are responsible for it. Scaling pods manually involves creating or deleting individual pods. Deployment allows ultimately deployment or replica sets allows easy scaling by specifying the desired number of replicas. The deployment controller adjusts the number of pods automatically. How about the updates? Directly, if you are running it manually, if you are running the pod manually, so directly updating a pod requires a manual intervention and can lead to downtime. What does this deployment or replica set supports? Rolling updates in the sense one by one. First of all, a new pod will be created, and then the previous pod will be, when you are sure that this is running, this is actually handling the requests and all, then the previous one will be deleted, and this is how it will just handle it, all the ones. It will create and delete. Allowing you to update a pod's new container images and roll out the changes gradually. If something goes wrong, you can roll back to the previous version. Again, if something went wrong, then the new replica set will be not applied. The new changes of your image will be not applied. Management, the pods, they are ephemeral, meaning they can be created and destroyed frequently. Deployments manages pods by ensuring that a specified number of replicas are running at any given time. If a pod fails, the deployment controller replaces it automatically. It's pretty simple, whatever the theory part is. Abstraction level, pod is the smallest and simplest Kubernetes object. It represents a single instance of running process in your cluster, typically containing one or more containers. When it comes to deployment, so is a high-level controller. Abstraction, ultimately, I must say, that manages a set of identical pods. It ensures the desired number of pods are running and provides declarative updates to the pods it manages. Ultimately, what happens? Deployment doesn't really manage pods directly. Rather, it creates replica sets, and replica sets manages the host. So let's keep the sequence in mind. Few things are not quite clear here, but yeah, just keep that sequence in mind. Going forward from here. So the next thing that we are going to be talking about replica set. We have talked about deployment. Ultimately, it is a top level abstraction file that has all the configuration that will be responsible for creating the replica set, and you already know what's going to be the flow. A replica set, let me even write the flow properly over here. You will configure everything inside deployment, and then deployment will be responsible for creating replica sets, and once it is done, replica sets will be responsible for creating a container, pods will be responsible for running the one or more containers. So this is how it just simply goes. Hope it makes sense. Okay, so this much we've covered. What is a replica set? A replica set in Kubernetes is a controller that ensures a specified number of ultimately replica set is responsible for running the pods, right? So this thing I'm talking about. So a replica set in Kubernetes is a controller that ensures a specified number of pods replicas are running at any given time. It is used to maintain a stable set of replicas or pods running in the cluster. Even some pods fail or deleted. So if you delete some pods or they are failed, it will respawn them, it will recreate them. So it will make sure that if 3 pods are you have set 3 as the desired number of replica, so 3 pods are gonna be running there anyhow. Let's continue from here on. When you create a deployment, you mention the amount of replicas you want for this specific pod to run. The deployment then creates a new replica set that is responsible for creating X number of pods and all. That is right. This is how this just simply goes. Series of events. User creates a deployment which creates replica sets, which creates pods. If pods go down, replica set controller ensures to bring them back up. This is the theory part. We will do it in action. But before that, let's simply cover the theory part. That would be the better best thing. And just a minute, have I missed something? Okay, kubegetal create deployment creates a deployment and blah blah blah. Okay, let's continue. So the next one is going to be series of events. So when you run the following command, ultimately a bunch of things happen. Kubegetal create deployment, nginx deployment, and nginx deployment image port replica 3. So kube create deployment. Okay, we can directly create the deployment, and nginx deployment we can name it, and yeah, let's even copy this thing. I would like to just even paste it here in my notes. This is something new. So we have a lot of things. I'm gonna be talking about each and everything, but over here, cluster is here, manifest.ml is here. Let me even this is my way to just write all the commands. I just keep copying and pasting the commands. If I'm just working with something's new, I just write the command here, and then later I'm gonna be coming back and talking about it. Kubegetal apply manifest. By the way, I have to talk about manifest, not manifest actually. Yes, and deployment can be created like this. So /code. Let me have this here. So ultimately, when it comes to deployment, or let me just bring it here. So when it comes to deployment, so you can directly create the deployment. So kubegetal create. You can configure the file. Of course, the file is here. Let me keep it here at the top. So or probably this is the same thing that I've been talking about right now, exactly how it works and all, and we don't really need to have this diagram, so let's simply remove this, not needed anymore. We know how it works, right? So deployment.ml, let me get this here. So coming back to this one, I'm gonna be keeping this particular file here. So ultimately, if you want to create the deployment directly, so kubegetal create deployment, that this is the name of the deployment, this is the image that this deployment will be running. So you can run anything manually actually, but it's better to just configure it and then just simply apply the configuration. Port number 80 and replicas, it will be running 3. So this deployment will be creating three replicas, and this is how it's gonna be going on. Pretty simple. By the way, coming back to this one, step by step breakdown, command line execution. You execute the command on a machine with the kubelet installed and configured to interact with your Kubernetes cluster. API request. Kubegetal sends a request to the Kubernetes API server to create a deployment resource with the specified parameters. Okay, API server processing. The API server receives the request, validates it, and then processes it. If a request is valid, the API server updates the desired state of the cluster stored in etcd. The desired state now includes the new deployment resources storage in etcd. The deployment definition is don't worry, this is just the theory part, but I do want to go through that so that I'm sure that I've gone through that, nothing else. Even if you know that well enough, it's better to just simply go through the theory part. Storage in etcd. The deployment definition is stored in etcd. The distributed key value stored used by Kubernetes to the deployment definition deployment definition is stored in etcd. The distributed key value stored used by Kubernetes to store all its configuration data and cluster state. Etcd is the source of the truth for the cluster's desired state. Okay. Deployment control monitoring. The deployment controller, which is part of kube controller manager, continuously watches the API server for changes to deployments. It detects the new deployments you created. So ultimately, whenever you create a new deployment, so kube controller manager, Kubernetes control manager, this will be responsible for checking, and then once the new changes are there, it will just simply deploy them and all. A replica set creation. The deployment controller creates a replica set based on the deployment specification. That's right. The replica set is responsible for maintaining a stable set of replica pods running at any given time. pods creation, the replica set controller, another part of the replica set controller. There is something called replica set controller as well. Another part of the kube controller manager ensures that the desired number of pods, for example 3, are created and running. It sends request to the API server, creates this pod. Ultimately, if you are creating the pod, if you are deleting the pod, if you are updating the pod, if you are creating the deployment, doesn't matter what you do using kubectl, at the end of the day, a request is sent, HTTP request is sent, and based on that request, new pods are created, new pods are, pods are deleted or updated. So this is how it just simply goes on. Apart from this particular thing, when you send the request, that HTTP request, that needs to have some configuration to make sure that you are an authenticated user. So if you make a request directly from your browser, it will be forbidden. You will not be able to send the, you will be able to send the request, but you will not get the desired result. And if you actually want to send it via browser, so somehow you will have to figure out a way to just simply send your authentication configuration as well. And what happens in terminal? In terminal, inside .cube/config, you already have your configuration. So whenever you send the request, that configuration containing the information that makes sure that you are authenticated is sent along. Okay, so this is how the things go on. Then we have pod creation, the replica set controller, another pod of kube controller manager, ensures that the desired number of pods are created and running. It sends request to the API server and create these pods. Okay, we have a scheduler. The Kubernetes scheduler watches for new pods that are in the pending and state, and it assigns these pods to suitable nodes in the cluster based on available resources and scheduling policies. We have node and kubelet. The kubelet on the selected nodes receives the pod specification from the API server. It then pulls the repository container image and Nginx, and in this case of course, and it starts the container. And then hierarchy, we have deployment. We have quite a lot to read. Never mind, let's simply keep reading. So hierarchical relationship, deployment, high level manager. A deployment is a high level manager, high level controller that manages the entire life cycle of an application, including updates, scaling, and rollbacks. Creates and manages replica sets. When you create or update a deployment, it creates or updates the replica sets to reflect the desired state of your application. Handles rolling updates and rollbacks. Deployments handle the complexity of updating applications by managing the creation of new replica sets and scaling down and old ones. So it will be doing what? It will be managing the new replica sets. If you just made some changes in the deployment, so it will be creating new replica set. That replica set will be responsible for creating new pods and all. And the old replica set will be scaled down slowly. So all the pods will be scaled down one by one. Replica set mid-level manager. So this is the mid-level manager. Top level, higher level, high level. Deployment is nothing but high level manager. A replica set is nothing but mid-level manager. A replica set ensures that, I'm going through the theory part, but honestly, it's not as difficult as people actually think it is. At least not yet. I didn't find it. It could be because I'm actually explaining. So after learning, I'm actually going live on YouTube and I'm explaining everything from my own side. So it feels like, okay, this is just simple stuff. If you are just simply learning theory part, it's gonna be getting more and more complex. So it's better whenever you are learning something, teach somebody or just simply create a channel on YouTube and start explaining that. If you do that, this is definitely gonna be helpful. So if in case you are watching this video right now, if you are, and definitely you are a coder, that is why you are learning. So this is the proven way to learn anything, maybe the fastest way possible. And just remember that for a long period of time, if you are learning something, teach that. It may seem like time wasting, but in long term, it is the best way to just simply keep learning and being sure that you have learned something and being able to just simply utilize the knowledge that you have. If you do that, definitely you will see the result. That is why I don't miss even a single topic. If I learn it, I share the learning here on YouTube anyhow, either today or tomorrow. But first of all, I will share the learning, then I will move to the next one. By the way, enough of motivation stuff. Coming back to the main topic. So we have talked about deployment. Then let's talk about the replica set. Mid-level manager. A replica set ensures that a specified number of identical pods are running at any given time. Maintains desired state of pods. It creates and deletes pods as needed to maintain the desired number of replicas. Level selector. This is the most important part. replica set is responsible for deleting the extra. Suppose you created lots of pods, so it will be deleting extra pods. So how will it check that whether that particular pod belongs to this replica set, and replica set recognizes the pods based on their labels. So you will be giving labels to the pods, and on the basis of the label, replica set will recognize the pod, and on the basis of that, it will check, okay, these are the pods under my what is that called? Under my area, not my area. What can I name it? So based on the labels that you give to the pods, replica set will recognize those pods, and once the replica set recognized those pods, that okay, these are the pods that belong to me, it will calculate total number of the pods. If the total number of the pods is less than replica set actually wants, then a replica set will create, and if the number of the pods goes above then the replica set actually wants, then in that case replica set will terminate the extra ones. So this is how the replica set simply manages the stuff, and at that time label selector plays the major role. Without label selector it's next to impossible. This is how replica set recognizes the pods that belong to that particular replica set, because there can be many replica sets, and those many replica sets may have many labels. So how we and those many replica sets may have many many pods. Those many pods may have many labels. So on the basis of only selector, on the replica set selector, based on the labels, they just simply select the right pods. I hope it's clear. Going ahead, lowest pods, lowest level unit. A pod is the smallest and simplest Kubernetes object. It represents a single instance of running process in your cluster and typically contains one or more container. A good question to ask at this point is why do you need a deployment and when a replica set is good enough to bring up and heal pods? Replica set is great, but if we are actually making some changes, and then if we actually want to get a new replica set created, ultimately whole overall life cycle. So ultimately deployment is responsible for managing the overall life cycle, that it will create new replica set in turn will be responsible for creating the new pods. This is how it just simply goes on. Alrighty, this particular thing is done as well. So this is all about the theory part, and let's not worry about deployments, and let's talk about again this is how the replica set is created. Don't worry, we will talk how replica set is actually created and how we are gonna be going through the stuff. So right now there's nothing but the codes. We will go through that. We can even apply the replica set after configuring that, get the details. We can even get the details and check the pods. We can check the pods, delete. We can even delete the replica set. Try adding a pod with nginx kubectl run nginx pod image label. Yeah, we can even do that. Ensure it gets terminated immediately because the RS already has the 3 pods. Delete the replica set kubectl delete RS. Okay, let's do one thing. Let me go through this thing from the beginning. The theory part will keep going on and on. It's better to just simply start this thing. So the first thing that we learned, again I'm gonna be going from starting. We learned about kind. Kind is nothing but a what is the full form of kind? The full form of kind is Kubernetes inside Docker. Kubernetes inside Docker, just like this. Okay, by the way, kind creates cluster. I just heard it. Let me check this thing as well. Kind full form cluster. Kubernetes in Docker. Okay, that is Kubernetes not inside in Docker. So let me be back here. That is actually Kubernetes in Docker. Okay, that makes sense. So kind creates cluster. So using client you can create a cluster. You can give it the name as well. If you give it the name, if you don't give it the name, it will get the name kind automatically. And you can get the cluster. You can get the this should be only one context. You can get the info about that, and lastly you can delete that, and you can just even add some aliases for the kubectl and all. We will be doing that. So let's simply go through everything from here. So first of all, we have to create a cluster. So kind, again, if you don't have kind install, you can just search how to install kind, and you will get the command to just simply install that. Even we talked about it yesterday. Kind create cluster. I want to create a cluster, and how will I create the cluster? And ultimately, what should be the name of the cluster? If I don't specify the name, automatically a new cluster will be created with the name kind. I want to name it local, so let's simply name it local. A cluster will be created here. So let's wait for a while. And once the cluster is created, we will be going ahead. It is just simply getting the kindest node image. This image needs to be here. If it is not, it will install it automatically. and once everything is done, it will be creating what? It will be creating a, what is that thing called? It will be creating a cluster. And the thing is that the cluster it will contain, that will be the control plane only, and this will have both. It will have a master node as well, it will have the worker nodes as well. So it is going to be the combination of both of them. That is not what we want. We will see how we will create separate control plane and worker managers, I mean node workers. But for now, let's simply go ahead. It is even giving us this command that yeah, it has been created. So if I say kind get clusters, so here I am getting that this local cluster has been created. This is the command. It is just simply saying that kubectl cluster info context is something like this. So if I want to know about that, so kubectl cluster and cluster info, and context is gonna be kind, is just the prepending stuff, and just add your name, cluster name, local, and this way I just know more about my I know more about the cluster that has been created, that this is running on this and all. Okay, so this particular thing is done. Let's simply clear the terminal, and what all have we covered? We have created this. We can even check it in the because this is nothing but Kubernetes in Docker. That simply means I should have a Docker process, and definitely we have a Docker process here running. That's amazing. What is the next thing? The last thing is that you can just simply delete that. So one more thing, Docker, not Docker. If you say kubectl, so if you are creating a cluster, okay, so if you are tackling with cluster stuff and all, at that time use kind. So kind is responsible for creating the cluster and all. But if you are interacting with the cluster, that simply means inside the cluster you are creating the deployment, you are creating the replica sets, you are creating the pods, you are getting the nodes. In that case, you will be using kubectl. So kubectl is nothing but a command line, and kubectl. And if you want to get pods, we have no pods. If you want to get nodes, we do have a node, and that node is local control plane. That is ready. The role is control plane, and it has ultimately this is how the things are going on. Okay, but the thing is that we want both. This is the combination of workers as well as the control plane. We want both the nodes, workers, and control plane separately. For that thing, we will just configure a few things here, and then on the basis of we'll be getting the things done. But before that, let me just simply stop it. For stopping it in the sense deleting it. So if we say kind get clusters, so this is the cluster I have. I'm gonna be deleting this cluster. So kind delete cluster. What is the name of the cluster that I want to delete? That is local. And once I run this, it will be deleted. Now if I say kind get clusters, so I don't have any clusters. Kind if I want to interact with that, so I will have to use kubectl get nodes. So kubectl is not found. Oh, kubectl is get nodes. Did you mean come on kubectl? Ultimately there is no cluster, and because of that thing, it is not able to recognize kubectl. If there are clusters, so it will be able to. Sorry, this code it is wrong. It's ctl, just like this. And it is telling me what unharmed did you mean to specify host or port? Ultimately there's nothing running on that particular port, and ultimately there are no clusters, and because of that thing it is not able to get nodes. It will not be able to get the pods and all. It will not be able to get anything at all. Okay, this much we have done. What is the next thing that we can do? The next thing is that going back from here, you can even set the alias. What is the alias? So if you actually if I just simply say aliases here, aliases, so these are the aliases that I have, and I can create new alias over here, alias, that whenever I write k, that k will be referencing to kubectl, just like this. So if I say k here, that is nothing but the kubectl. So either I write kubectl here, or I write k here. Both the things are the same. So I mean, this is how we can just simply set the aliasage. This thing we have done. Let's talk about this cluster.ml. So I'm gonna be creating a cluster.ml file and gonna be copying the things pasted here. So vi cluster.ml, either you call it YML or YAML, both the things are same. Let's simply go ahead with this. I'm gonna be copying this here, and I'm gonna be explaining exactly what I'm doing here. Copy and paste. So what am I doing here? I'm trying to create a cluster. Again, in real world, you never create a cluster manually. Here we are creating cluster manually because we are learning. Because you must know that at the end of the day, we will be creating something called deployment. Inside the deployment, everything will be configured automatically. Cluster, and when it comes to the cluster, so you don't need to use client. I mean, of course, locally you need to use kind to just simply create the cluster. When it comes to deployment and all, production applications and all, you directly get the clusters created, so you don't need to worry about it. Again, how you get that, I don't know. I'll be knowing what else. But in deployment, definitely we create the cluster. So let's simply create the cluster here. So this is the thing, and here the kind is the cluster. We want to create a cluster. This is the version of that. And what nodes do we want? There can be many nodes. One node, we had only one node by default when we created it manually, and right now I'm specifying some roles here that I want a control plane. I want two workers here. So role worker. That simply means I will have two workers. Let me save it here, and once it is saved, so I have a file called cluster.ml. It's better to name it clusters. That's okay, let's name it cluster.ml. So what is the problem here? How about naming clusters? Naming convention matters a lot. You cannot name it anything. If I name it cluster, I'm getting the error. So let's name it clusters. So yeah, naming does matter a lot. So make sure it has the right name. Once it has the right name, now I can just simply apply it. So kube I'm gonna be applying. What will I apply? I will apply everything inside this cluster.ml file. So I will have a file, and what is the file name? File name is F stands for file name here. Clusters.ml. Once I just kind apply F clusters.ml. How do we apply that? We kind create cluster, and then alrighty. So ultimately the thing is that when you are creating something inside the cluster, at that time this is the way you write. So you write kubectl apply F and your configuration name. Okay, so your file name over here. So this way you do it inside the cluster, not when you are creating the cluster. For creating the cluster, that is why I have created proper things here. I have all the commands, and this is how you do it. Kind create cluster. You will provide the configuration. This is the configuration, and you will be giving it the name as well. So let's do that. So kind create, I'm gonna be creating the cluster, and when I'm creating the cluster, I have to specify the configuration. What is the configuration? The configuration is clusters.ml, and what should be the name? The name is gonna be local over here. Either you say name local or you say n local, that both the things are same. If you run this, cluster will be created with 3 nodes, and one of them is gonna be control panel, 2 of them are gonna be workers. Simply check this thing out. Hopefully it's gonna be created very soon. And we have to go through a lot. We have to, at the end of the day, we have to create a deployment file, and then we have to get the things done. So yeah, never mind. By the way, once this is created, so it is telling me again that you can know more about it. I don't want to do that. First of all, I want to check the kind get clusters, number of clusters that I have. I have only one cluster, that is the local one. Then I want to check the nodes. So if I want to interact with the cluster, so kubectl get nodes, just like this. So I'm gonna be getting the nodes here. So I have a local control plane. Again, this local is just the name of my cluster, and control plane is the master node, and these are the worker nodes that we have. And ultimately 2 workers nodes I have, because 2 only I specified over there. Even I can say k get nodes will do the same, because k stands for kubectl. I have set this alias, so maybe I will be using kubectl, or maybe I'm using k. So just understand that k stands for kubectl here. Okay, I hope it does make sense. Apart from this particular thing, if you try to get a k get or kubectl get pods, you will not be able to get pods over here. That simply means you will have to create the pods. As simple as that. The question comes, how will you create the pods? So again, we will be going through it from here. So we have created this, and now if we get the pods, we are not gonna be getting the pods. So how do we create the pods? Let's talk about that thing. So for creating the pods, pod is gonna be created inside the cluster itself, and whenever you are creating anything or you are interacting with the cluster, you will be using kubectl command line. So kubectl, and what do you want to do? You want to create the pod, right? So again, you cannot create the pod directly. What is a pod? Pod is just a kind of a machine that runs the container. So pod is responsible for running the container. So if you actually just simply run that particular image, the pod will automatically created. So kubectl run, what is gonna be the name of the pod? So this is how we just simply run the pod, and in turn the pod will be running the container. So kubectl run, what should be the name? So suppose the name is nginx image, nginx pod. So this is the pod. What is gonna be the image? Image is gonna be nginx nginx, it will be running this image. What should be the port here? Either you specify the port or not, that doesn't really matter. Suppose the port number is 80. If you run this, your pod nginx pod will be created. That simply means pod has been created right now. And if I say kubectl get pods, so right now I'm getting this pod. What is this saying? That status is container creating. That simply means pod is created right now. Inside the pod a container is being created, and what will that container be running? That container will be running the image itself that we have specified. There is one pod, but it's not ready. Let me run it again, kubectl get pods, and this time what am I getting? One by one. That simply means there is a one pod, and that is of course running. The status is running, restarts 0, age 27 seconds ago and all. So ultimately we have a pod running. And again, there are many things that you can do over here. You can know more about the pod. So you can just simply say kubectl logs, and you can check out the logs of the pod. So if you just simply copy it from here and paste it here, so this way you will be getting the logs. So I mean, these are the logs from what? From the nginx. That okay, nginx has started and all. Not only that, you can even say kubectl get I mean, you can describe the pod. Describing in the sense you will be knowing everything about the pod. So kubectl describe pod, and what is the name of the pod? The name of the pod is this. So let me copy the name from here. I mean, these are nothing but commands, and I have saved them in my notes as well. I will be showing them. So kubectl describe pod. Let's simply run this. So it simply tells me about everything, and what it tells me that the name of the pod is nginx pod, namespace is default, priority is 0, service amount account default, node it is running on local worker 2. So the pod that we created, that is running on local worker 2, and mainly scheduler Kubernetes scheduler is responsible for assigning the right pod to the right node, and this time it's been assigned to load node local worker 2. Okay. And then start time is this, labels is this, label is run nginx pod. So this is the label that it has. So just keep this particular thing in mind, and this label matters a lot at the end of the day. Okay, and we could have set the label from our on side. I'm gonna be even doing that, and this got automatically set. And name is nginx pod. We did not specify any label, so because of that thing the label got set automatically. Once we specify the label, that particular label is gonna be here, and on the basis of this label only, ReplicaSet is simply gets the right pods that belongs to that ReplicaSet, because if the label inside the ReplicaSet matches to this particular label of the pod, that simply means that particular pod belongs to the ReplicaSet. Annotations, status is running, IP address, containers. We have a pod. Inside the pod we have only one container running. We can have even many containers running. That container ID is this, image is nginx, image ID is this, port number is 80, host port this, and this is how it's gonna be going on. And you have some conditions over here and all. You can just simply read more about them. And we have even volumes here, and lastly we have events here. So first of all, successfully assigned default nginx pod to the local worker 2. So first of all, the pod that we created that got assigned to local worker 2. After that, it started pulling the image of nginx. After that, once the image got pulled off the nginx, it started the container. It created the container, and it started the container. So these are the things that actually happened here. Pretty simple, understandable. Okay, now we are gonna be making some changes here. What are gonna be those changes? First of all, if I say kubectl get pods, so I'm getting this pod. What am I gonna be doing? I'm gonna be deleting this pod. Even you can see the pod in the watch mode, just like this. So what will happen? Right now you are inside that particular environment. You are not getting out of that. So whenever a new pod is added, that will automatically be shown here. But okay, let's not worry about that. Not only that, there is something called follow. No, it doesn't work here. It works somewhere else. Where? Follow. I think when we create something. Okay, I will talk about this. So kubectl get pods. I'm getting the pods right here. What is the next thing? The next thing is that I want to delete it. So kubectl delete. I want to delete which pod? This is the pod that I want to delete. So let me just simply delete this pod from here. Done. The pod is going to be deleted. Okay, interesting job. The pod is deleted. Right now if I say kubectl get pods, so there are no pods. Kubectl get nodes. There are nodes. There are still 3 nodes, but there is no pod inside them. What is the next thing that I can do? I'm gonna be creating the pod again. So kubectl run. What is the name? The name is nginx pod. This is the name of the pod, and the image is gonna be what? The image is gonna be nginx, and this time I will not be specifying the port number over here. Okay, so earlier I specified port 80. I'm not gonna be specifying this. Then what will happen? Let's simply check this. Kubectl get ports. I got the ports. Kubectl describe pod. Which pod I want to describe? I want to describe this pod. Copy, paste, enter. Then you will know more about it coming back to this one. I did not specify the pod. Name is this, and at the end of the day, what is the port? We don't have any port number here. Do we have that? Okay, we don't have, but it is still running. Container, this is the container, and it is running on host port. So port hasn't been specified here. So even without the port, it runs, and this port does only one job. It is just for the description purposes and all. Right now there is no port because we haven't specified. And in case I'm gonna be creating a pod, Nginx pod 1. This is the new one that I'm creating, and this time I'm gonna be specifying the port, but that port is gonna be 3000. Even this will not make any difference. I mean, it is just for the description purpose. So if I say get kubectl get pods, so this time I will have two pods. One of them is getting created, another one was already running. So let me just run it one more time. So right now it has been created, and the name is Nginx pod 1. So okay, let me describe that as well. So docker, not docker, kubectl describe. I'm gonna be describing this, and I wanna describe a pod. What is the pod name? The pod name is this, Nginx pod 1. Let me run this, and if you actually check this thing here again, so this is the name of the pod. This is we did not specify any label, so the name of the pod became the label. We will be specifying it as well. And apart from this particular thing, at last we have this port number 3000. Again, this is for the description purpose. Even if I have this, I mean added 3000 here, it is still working, though by default Nginx runs on port 80, if you know that. Okay, so this much we have covered. So if I try to get a kubectl get a pods, so come on here, wow, pod also works. By the way, I'm gonna be getting the pods. So I have these two over here, and I'm gonna be deleting it. Okay, so how will I delete the pods? Pretty simple stuff. Kubectl delete. I'm gonna be deleting a pod. What is the pod? Nginx pod. Let me delete this. One has been deleted, and then let me delete the another one as well. Kubectl delete pod. I'm gonna be deleting the another one as well. Nginx pod 1. And this way I'm gonna be deleting both of them. Okay, both of them have been deleted. Right now if I try to get them, kubectl get pods, I'm not gonna be getting anyone. This time I will be creating a pod, but with a label. So kubectl create, run. The name is gonna be Nginx pod. Image is gonna be Nginx label. I hope this is how I specify the labels. How can I make sure that this is the right way? Hopefully this is gonna be the right. So labels are gonna be what? Label is gonna be app Nginx, just like this. And port you can specify or not, ultimately up to you. Let's make it port 80. Oh, something went wrong. What is the problem here? Unexpected label. This should be equals to app equals to, this is gonna be the label. This is how you specify the label. And once you run this, so it has been created. And right now if you try to have a kubectl, let's simply write K. K stands for kubectl, if you know the alias that I have created, or let me write it properly. Even if you say kubectl K get pods, it will be returning the same. This is the pod that is running. And then K describe, K stands for kubectl, let me write it properly. Kubectl describe, and Nginx pod. No, I need to have pod here. Just like this. Let's simply run this. And right now again you can just simply go through the messages here. Ultimately the important thing, name is Nginx pod, label is app Nginx. We have given it the label, and on the basis of this thing, even ReplicaSet selectors, select the pods or just identify the pods and all. Just give me a second, I'll be right back. Hang on for a sec. Hello, hello, hello. I'm back. No, 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 no. Alrighty, let's continue. And what are we gonna be discussing next? First of all, we have created the label successfully. That's really a good stuff. Let's talk about the commands that I have in my notes. So first of all, we created the cluster config using this local. So this is the configuration that I have. The name should always be clusters.ml. First of all, make that thing in, keep that thing in mind. And then we can just simply create the cluster. Once cluster is created, we can get the nodes, we can get the pods, we can get the pods in the watching state, and then we can get the log of that particular pod that you have created. And we can even follow the logs. Okay, this is mainly used for following the logs. Oh, interesting stuff. Get logs follow. Ha ha ha. Okay, let's try this thing out. So cube total get pods. These are the pods that I have, and now I'm gonna be checking the logs of the pods. So cube total logs of this pod nginx app, sorry, nginx pod. If I run this, so these are the pods that I have, but the thing is that at the end it exited, and if you don't want to exit it, rather you want to keep following the new logs and all, in that case you just can use this follow tag over here, and this will not exit. Right now whatever new request you get here, you will be, all the requests are going to be shown here. As simple as that. I hope this does make sense. Coming back to this one, and there is one more thing, get pods in the verbose manner. Let me show you exactly what it does. So by default you get a cube total get pods like this, and it just simply shows you the pods. Right now you can get the same thing in the verbose manner. Verbose in the sense it will be giving you more information. So if you just simply run this, it simply tells that okay, this is the nginx pod that is running, but at the end of the day there is a verb get. Ultimately get request goes to this particular URL, and the configuration is automatically selected. These are the headers that are selected and all. So ultimately the request goes with proper headers so that you are considered as an authentic user. And this verbose number you can just simply increase or decrease. You can keep it 20, 100, depends on how much you keep. Hopefully it goes to that. You can keep it 20 for sure. Cube total get cube total get pods verbose is gonna be number 20. So you will be getting more text, I mean this way you will be getting more things and all. That's it. This is how it just simply goes on. If you actually have a look at the text that you get, it is more than earlier, right? So it just simply goes on like this. If you keep it cube total get pods verbose is gonna be supposed to, so you will be giving getting less. So the higher the number is, the higher the result length of result that you get. Okay, so this is how the things go on. And right now once we have gone with this, so this thing is that cube total run nginx image, specify the port number. Port doesn't really do anything. This is just for the description purpose and all. We have gone through this. And similarly you can run the image of Mongo, and similarly you can describe it, you can delete it. We have gone through all these things. What is the next thing? The next thing is that right now what have we been doing? We have been creating the pods, right, on or on, and this time we will be configuring it. So we will create a manifest.ml file, and that ml file will be responsible for creating the pod. So what will be the good thing of this? The good thing will be we won't have to create pods manually, right? So I'm gonna be just simply copying this thing. I will be telling you exactly what it does. So let's clear everything. Create vi manifest.ml file here. Once the manifest.ml file is created, simply paste everything. And what it does, the API version is v1. What you want to create? You want to create cluster, pod. Earlier you created cluster, you have the configuration for that. Right now you want to create pod, so you have the configuration for this. Metadata is what is the name? The name is nginx. You can keep it nginx pod as well. So let me change the name here. Coming back to this one, because nginx pod is gonna be the name. Depends on exactly what you want to keep. Then this is the name of the pod that you are creating. As simple as that. You want to create a pod. Okay, what is the name of the pod? The name of the pod is an nginx, and then you want to create the inside the pod you want some containers to to be running. So what is the name of the container? Nginx, and you can even name it Nginx app. What is the image? Nginx image is gonna be running. What is the port number? Port number is 80. This is just for the specifying purpose. And one more thing, you can specify the labels. And how do we specify the label inside this? Just a minute. I hope that has been mentioned somewhere or the other. Labels app Nginx. I think you will have to use template here for this. This label belongs to what? This label belongs to that particular pod, right? So you had better have this template. So it should not be specified here. If I am not wrong, let me be sure about this exactly where it should be specified. So we have specs. It should be specified inside the metadata only. So let me do one thing. Inside the metadata, I'm gonna be giving this pod the label as well. Hopefully this is right. Label is gonna be what? Label is gonna be labels actually. Labels. That's gonna be app Nginx, right? I'm not sure about this thing, but app Nginx pod. App Nginx. This is gonna be label, and hopefully this is right. But let's see. If it is not right, of course we are gonna be getting the errors. What else? But let's see what's gonna be happening here. So let me just simply save it, and let me apply it. So kubectl apply. What is the file name? File name is manifest that we have created. Run it. And warning, there is a problem. What is the problem? Resources Nginx pod is missing. Kubernetes should only use the resource. Ultimately, I think whatever changes we made, so vi manifest ml. Let me delete this. I don't know how it's added here. So I'm gonna be removing this name from here. Label from here, and later we'll see how the name is, label is actually added. First of all, let me run this much. If it gets right, then I will figure out how the labels are added. Then I will just simply add the label, and let me run it again. Wow, lovely. Why? Kubectl get pods. We already have one pod ready. So kubectl delete pod Nginx pod. This is gonna be the name of the pod here. Let's run it. That pod has been deleted. So kubectl get pods. I'm not gonna be getting any pod, and this time kubectl apply. I want to apply what? I wanna apply this file manifest. Let's simply run this. It has been created, and if I check this thing out, so kubectl. So on the basis of this manifest file, what this manifest file does, if we actually have a look at this manifest file that we have created, deleted that. Not deleted that, new file. It simply says that okay, this is the file, okay, that's fine, and inside that I wanna run a container. That container name is gonna be this, image is gonna be this, port number is gonna be this. As simple as that. Simply, it does make sense. Coming back to this one, so if I say kubectl get pods, I'm gonna be getting a pod. The name of the pod is Nginx, and if I check out the few things here, kubectl describe pod Nginx pod. So I'm gonna be describing it, and of course you can just simply read through it. Let's go to the top, and at the top here the label is none, so there is no label set by default. So we will be knowing exactly how we set the label, and the name is Nginx pod, and a few more things are here, and at the end of the day you have a port set here. So ultimately this is working, but what we want, kubectl get pods, and let me delete this pod right now. So kubectl delete pod. How do you delete the pod? You delete the pod, you just with the name, copy paste enter. It is deleted. Now the next thing is that question, how to add the label to the manifest.ml file. Labels, selectors, Kubernetes, metadata. So this is how you can just simply add the label, not this. So inside metadata you have the name, and just inside this is the same. What we doing the same thing here. So you can have many labels over here. I'm gonna be having app Nginx here. That would be fine. Interesting, lovely. So I was actually doing the thing the right way. Manifest.ml. So inside the metadata, just like this, I'm gonna be adding labels here, and the labels are gonna be app nginx. Yeah, that's it. Let me save it. And if I create the the pod using this configuration, so kubectl, if you want to use the configuration from the manifest file, you have to just simply apply that. So apply the file name is gonna be manifest.ml. Let's simply run this. It has been created. Then kubectl k get pods. I mean, this is how you can k stands for kubectl here, because I have added the layers. So nginx pod is running, and right now if I try to get a kubectl describe and kubectl describe a pod, what is the pod name? Nginx pod. And this time you should be hopefully getting the, coming back to this one, name is here, labels app nginx. So this is the name that we have here. Interesting stuff. And apart from this particular thing, you can even add more labels over here. So manifest.ml. So it's not like you can have only one label, you can have many labels here. So in interactive mode and input mode, insert mode ultimately, and suppose environment, that's gonna be node, probably node environment. Environment is what? What was here mentioned? Environment production. Okay. I was saying environment node, such a crazy thing. Delete this. Environment production, save it. Now I will have to delete the previous node, of course, previous pod, to just get a new one, because if I directly try to create the manifest file, I will get the error. Oh yeah, I didn't get the error. Okay, so the pod that I had, that pod itself got configured. Configuring in the sense, if I say get a kubectl get pods, so it is just simply saying one by one is running. So whenever I just simply run this configured, I mean whenever I run this whenever I apply the manifest.ml again, so what happens, the previous pod gets drained, terminated, a new pod is created. So let me just run it really quick, this and this. Yeah, got it or what? Kubectl get pod, I have unchanged, so this is not changed here. I need to change something inside that. VIML, let me add the extra space here. I think that way it will be changed in insert mode, just like this. Hopefully this much should be fine. And if I say kubectl get pods, right, first of all I'm gonna be applying the changes, and after that I'm gonna be getting it, well, unchanged. Okay, never mind. Ultimately what happens, whenever you make the changes at the time, previous one just stops, the new one gets created. And let me add, I wanna check this here. I'm gonna be adding one more environment, or nginx app. Let me give it this name. Yeah, that should be fine. This is definitely changed this time. And what I want, first of all, I want to get all the pods. Right now I have this pod running, and then I'm gonna run this command. I made it really quick. It got configured, but it is just simply running the things like this. It doesn't really make any changes. Maybe it just simply does this automatically. And if I just try to describe this to kubectl describe pod and nginx pod, if I go here inside the label, I have two labels here. It does make sense. Okay, so this particular thing is done. What is the next thing that I can do? We have gone through actually a lot of things. We have gone through this. We can even have labels here, not here. Over here, if we wanted to have labels, so labels, we can have labels app index if we want to. Someone is just knocking something. Okay, so this much is done. And even we know that we can just simply write kubectl f for manifest.ml. F stands for file name over here. If we want to delete a pod, we can just simply delete the pod like this, and this thing is also done. Let's talk about the replica set, because here we are doing what? We are creating the pod automatically. First of all, we created the cluster. That is fine, because most of the time we will get the cluster from the provider side and all. But when it comes to the pods, we should not create the pods. And again, if we are creating the pod and if something crashes, we will have to manually restart the pod. So what is the job of this replica set? Replica set is responsible for managing the pods. So it will, what are you doing here? You are just simply saying that you want to, the version is this, let's forget about the version. What you want to create? You want to create a replica set. What should be the metadata? The metadata should be Nginx replica set. Again, this is the name of what? This is the name of replica set that you are creating. And what are the specifications here? You want 3 replica sets. 3 replica sets in the sense there are gonna be 3 replica sets. They will be responsible. Ultimately, 3 pods are gonna be running. So when you create replica sets, so here you just simply mention replicas. So there are gonna be 3 replicas. That simply means 3 pods are gonna be running. Okay, that's simple. Selector, what is the selector? Inside the selector you are saving the match labels, and that match label is app. This replica, how will it be selecting the label? Just earlier I discussed that when you create a pod, you give pod a right label so that your replica set, what is the replica set? This is nothing but a kind of a manager that manages all the pods. So how will this manager, how will this replica set will know that this particular pod belongs to me, and for that particular thing it uses labels. So you specify the label. We have talked about it exactly, how we specify the label to the pod that we create, and you can do it manually, and here even in the template we are doing the same thing. So we have talked about this. So on the basis of how does the replica set matches them? So it matches it based on this particular label. So if any pod has app nginx label, that simply means that particular pod belongs to this particular replica set. As simple as that. I hope it does make sense. On the basis of this selector only, replica sets are able to identify the pods, and then they are able to calculate the number of the pods. On the basis of that thing, they increase or decrease the number of pods. I hope it does make sense. Let's go ahead, and here we have the template. Simple. What is the replica set? Inside the replica set, I will configure everything. I will configure how many replicas I want, how many pods I want. I will configure on the basis of which label it will be finding them. It will be checking whether that belongs to me or not. So on the basis of app nginx, and what kind of pod it should be running. So the template is gonna be here. So metadata is gonna be labels, and inside the label I have specified this nginx. So ultimately I'm gonna be running nginx pod here. So the pod will be responsible for running nginx. What is should be the label? This is what defines the pod. So the label should be nginx, and as I have defined this label over here, that simply means whenever the pod is created, that pod will have this particular label, and because of this thing, and I have specified it here, so the replica set will be matching for this particular label app nginx, and as while creating I'm already setting this particular label, so replica set will be able to find this particular label and will be able to find the pod as well. What are the specifications over here? I wanna run a container. That container will be running nginx, and the latest image, and that's it. I mean, it does make sense, right? We have talked about it a lot. It's pretty simple. This is the replica set. What is the replica set? Replica set is responsible for maintaining the pods, running the pods, anything. I mean, yeah, mostly something like this. And here you are specifying that how many pods you want, how many replicas you want. Here you are specifying that on this particular selector, on this particular label, replica set will be looking for the pods, whether they belong to me or not. And then what you want to run, what should be the template name? You want 3 replicas to run, you want 3 pods to run, but what should be the overall template? What should it actually run in those pods? So this particular thing will be running in those 3 pods. So first of all, label, you are just simply assigning for that pod. For that pod, this should be the label. Label should be app nginx. Even we have talked about this here at the top, that you can specify the label in the metadata. You can even give it the name. Let's not worry about the name, it will automatically be created. And then specs, what are the containers that you want to run? So I'm just simply saying inside those pods I want to run only 1 container. Is it possible to run 2 containers? Yes, it is possible. Are we gonna be doing that? Yes, we are gonna be doing that, but let's go with the first one. So containers, name nginx, image nginx latest, port number is gonna be 80. Again, is this optional? Definitely optional. It is just for the description purpose and all. Even if you don't give it, it will be running. So shall we copy it? Of course. And what is the name of the file? rs.ml. That is really important. So let's simply copy this thing from here. Once it is copied, let me go to here. Let me clear the terminal, and vi